All right, so now that we know what the second derivative is and how it changes our graph, right? It's talking about the curvature, the kind of concavity of our function. We're going to look at the second derivative test. So the test says this: suppose our derivative equals 0, so that means it's a critical point, and the second derivative is continuous. So it's just basically you can take the derivative and it exists. All right, if my second derivative is less than 0, then that means f has a local maximum at c. Because if my second derivative is negative, that means it's concave down like a frown. And right in the middle at c, that is my local max. All right, so if my function is concave down, that critical point is going to be a maximum. And if my second derivative is positive, that means it's concave up. And if it's concave up, that local, or that critical point is going to be a local minimum. All right, so if we just think about with the shape of concavity, concave up, there's a bottom there, that's going to be a minimum. Concave down, there's a top, there's going to be a maximum. And if the second derivative is also 0, we don't know anything. It could be a local maximum, it could be a minimum, it could be neither. All right, so it's just not conclusive if we don't have a positive or negative second derivative. All right, so now we're going to use the second derivative test to find the local, or find the value of the local maximum of this function. All right, so what we're going to do is we're going to take f prime of x. So we're talking about a local maximum. We first need to find the critical points because that's where the max and mins happen. So we're going to use the first derivative first. It's going to be x squared plus 8x minus 9. And we know our local maxes or mins happen at critical points, which is when this is 0. Also where it's undefined, but this isn't undefined because it's a polynomial. And this is going to be plus 9, x minus 1. That's negative 9 and 1. All right, so these are our critical points. We could go from here and do the first derivative test, would be making a whole number line. Or we can use the second derivative test and now say we take the second derivative. It's going to be 2x plus 8. And we're going to figure out the second derivative is positive or negative at these critical points. So the first thing I'm going to do is figure out the second derivative of negative 9, which is negative 18 plus 8 is negative 10. And the second derivative of positive 1, and that's positive 10. So at negative 9, my second derivative is negative, which means it's concave down like a frown. At 1, my second derivative is positive, which means it's concave up like a cup. Again, where's the maximum going to happen? The maximum is going to happen at the concave down point. So our local max is at x equals negative 9. As you can see, we have to put a lot of stuff together from the last few videos. How do we find local maxes and mins? We have to find our critical points. So we take our derivative and set it equal to 0, or figure out where it does not exist. All right, so those are our critical points, and we got those here. And if we want to use the second derivative test, we figure out our second derivative and plug in those critical points, and those will tell us if they're maxes or mins. So negative 9 would give us a local max, 1 would give us a local min. All right, so this is how we use the second derivative test in conjunction with the first derivative to find critical points.